Hey everybody, video number 7, last video of the unit. Woohoo! Solutions, freezing point, and boiling point manipulation. After today's video, you'll predict how adding a solute will change the physical properties like boiling point and freezing point for the solvent, in most cases water, and some very practical purposes for us. Is how we're going to make ice cream in lab, and this is why we salt the roads. So let's see what's going on with all that stuff there, and some science here is going to help us understand some very practical things for us. So, what happens to the boiling point of water when a solute is added? This is one confusing semi-topic just based on the answer, but what happens is the boiling point goes up and the freezing point goes down. It happens simultaneously. They don't just it's not just one changes. The problem is that for that solution, I can only test one of them at a time. So the boiling point is going to go from 100 degrees to, let's say, 105 degrees. Well, you'd have to test that at 105 degrees, and it's absolutely impossible to see that the freezing point would also change at that same time because I'm 100 degrees away. And now I'm more than 100 degrees away because I'm going to take that freezing point and make it from 0 degrees Celsius to something like -5 degrees Celsius. And in Fahrenheit, it goes down farther because of the conversion. And that's why we use it to put it on the roads. We don't test both at the same time. We can only test one, but they both happen simultaneously. The freezing point is going to change and the boiling point is going to change all at the same time. And then the more stuff I put in, the more it changes. So the higher the higher the concentration, the greater the change in boiling point and freezing point. So more stuff, more interruption, and greater change in temperature. And physically, what happens is stuff gets in between the water molecules so that they can't bond together and form that rigid structure. So that takes, I have to get more and more heat taken out of there, hence lowering the freezing point. And the same thing happens actually in the liquid form. They're near the dissolved particles are all throughout, and the ones that are near the surface are inhibiting those water molecules from leaving. Like they have to get more kinetic energy to get around that stuff to get out. And it's almost like a physical internal barrier, and hence the boiling point goes up. More stuff, more change. And then here's the part for us for chemistry is ionics do a much better job than covalents, all right, because ionics dissociate. So if I put in 1 mole of sodium chloride salt and 1 mole of sugar, I get 1 mole of sugar molecules in solution. But because the ionic will dissociate into two ions, I now have 2 moles of ions in solution. 2 moles of ions in solution is way more effective than 1 mole of molecules, just because simply more. So ionics do a much better job. So the more ions now, the greater the effect. And so some of the part 2 type questions is dealing with ionics number 1 on table F that will dissolve, and then the one that has 3 ions will do even better than the one that has 2 ions. Okay. A little chart to fill out about covalence and ionics and what happens. So what happens when it dissolves? It creates a 1-to-1 ratio, 1 mole of molecules for every 1 mole added. Okay. What happens to the boiling point of water? It goes up, but I'm going to say it goes up a little or modestly. And what happens to the freezing point of water? Well, it's going to decrease, and it's going to only decrease modestly. The opposite's true with ionics as far as the amount. I'm going to create an X to 1 ratio now. I'm going to have X moles of ions for every mole added. And that has to do with the number of ions within the molecule. So I just put X in because it could change. Sodium chloride, salt, has 2 ions in it, where calcium chloride, CaCl2, has 3 moles of ions in it. So calcium and then 2 moles of chlorine ions. So the calcium chloride is going to have a greater effect than sodium chloride just because of the number of ions within solution. What happens to the boiling point? Well, it's going to increase extremely or a lot compared to relative to covalence. And the same is true for the freezing point. It will decrease extremely or greater consequence. The magnitude of the change is much better, much bigger. Okay? Breaking apart ionics and covalence. So I know you got this long piece, so I literally just split it in half, and I'm going to do ionics on one side and covalence on the other side. If you want to do ionics across the top and covalence across the bottom, by all means, okay. But the effect is increased by the number of moles of an ionic compound are increased. So the more moles, the more the increase in boiling point and the decrease in freezing point. The effect is multiplied by the number of ions in compound. Hence, Li has 2 ions in solution, LiBr, where magnesium chloride has 3 ions in solution. So these are examples for you to understand what I'm talking about. By all means, if you can't fit all that in, only write, the top pieces is fine. Okay? The examples are for you to understand what I'm talking about with the other piece. Okay, the effect is increased by the number of moles of a covalent compound I'm added, but that's where the effect stops. Because for 1 mole in, I get 1 mole of molecules in solution, so I can't compound it. I can't exponentiate it, if you will, the change. So covalents are not very handy for this. Okay, example, PlCl3 is 1 mole of 1 molecule in solution. For every 1 mole I put in, I get 1 molecule in solution. I'm not really, even though it looks almost like it's ionic, it's not, and it's not a lot of bang for your buck, if you will. Some quick example questions, and we'll call it a unit. Ready? KCl is added to water. Will it dissolve? Well, KCl, I use table F. All chlorides dissolve except for with silver, mercury, or lead. So this is going to dissolve. It's also ionic because K is a metal. So how many ions will it dissociate into? 2. K plus Cl minus. Would the solution raise the boiling point of water? Well, absolutely. And would it decrease the freezing point? Well, absolutely. Okay. Next one, all covalent. This is actually an alcohol. Will it dissolve? I'm going to say yes because it's a polar molecule. The actual real word is to it's miscible, is what we say. 2 liquids are miscible. How many ions will it dissociate into? Technically none, but as far as we're talking here, 1 mole of in, 1 mole of molecules in. So that's what it's kind of referring to, right? Would the solution raise the boiling point of water? Well, it certainly would. Would it decrease the boiling point of water? Yes, it would. But compared to an ionic, would this compound have a greater or lesser effect? Because it's covalent, it will be lesser. I only get that 1 mole of molecules in solution, so not as powerful as 2 moles. Okay. A few more and we'll be done. Here's an example, and this is a very typical question. If I were to actually rank them, this would be harder. If I have to just say which one is going to lower the freezing point the most, the answer is going to be MgCl2 because first it dissolves, second it dissociates, and then it dissociates into 3 ions. LiCl dissociates into 1 ion. MgCO3 does not dissolve at all on table F, so that would be last. And the NO2 would actually be in front of it because it at least will dissolve into the solution. Okay, so MgCl2 is going to have a greater effect. Why? Because it forms 3 moles of ions for every 1 mole added. Okay. When copper chloride is added to solution, will it dissolve? Yes, all chlorides dissolve, except for with silver, mercury, or lead. Copper is neither of those. This will give me 3 moles of ions, though. And so will it raise the boiling point? Yes. And will it decrease the freezing point? Yes. And this one will do better than even the first ionic we did on the last example, and do even much better than the covalent we did in example number 2. Okay. I think this is it. We're done. I think. Got my fingers crossed. NH3 added to dissolve, or added, will it dissolve? Yes, it's polar and it's on table G. It is technically, I believe, a gas though. How many solids will it dissociate into? 1, because again, it's covalent, so it doesn't dissociate into any actual ions. It'll just have 1 mole of molecules for every mole of stuff I add. Would the solution raise the boiling point? Yes, and yes, and again, lesser because it's covalent and not ionic. And then last is number 6. Again, I'm not ranking these, but if I was to rank them, it would be MgF2 first, LiF second, and probably silver nitrate third this time because that will nitrates all dissolve. And why? Because they form 3 moles of ions for every 1 mole of compound added. And with that, we are done for the unit. Sorry, the light went out, killing me. Do your practice and do all your labs, and let's test out this unit and get on.